I'm Bhaskar, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology. In today's class, we are going to see applications of jet transforms to solve difference equations. To solve difference equations. Right. So in this, we will use in the jet transforms, these formulas we use in final value theorems. Jet transform of un plus 1 equal to z into u bar of z minus u naught. Jet transform of un plus 2 equal to z square into u bar of z minus u naught minus u1 into z power minus 1. Right. Procedure. How do you simplify this? We have to see. We take jet transform. We take jet transform. We take jet transform on both sides of the difference equation. Both sides of the difference equation. Second one should be, we use above expression. We use above expression. We use above expression in the place of un plus 1 comma un plus 2. Third one, we obtain u bar of z equal to z transform of un as a function of z. Next, the required solution un equal to z inverse of u bar of z. Now, see, first what we will do, they will give z equation. For that equation, we will apply both sides z transform. Then we will apply this expression in the place of un plus 1, un plus 2. Then we will get a u bar of z. For that, we will apply u bar of z equal to z transform of un. We know that. So now un equal to z inverse of u bar of z. That u bar of z will simplify by using partial fractions. Right. So we'll see that first problem. Solve by using jet transforms. Solve by using jet transforms. Yn plus 2 minus 4 into yn equal to 0, given that y naught equal to 0 and y1 equal to 2. Right. How do you simplify that? So we'll simplify this. First, what is given we will write. So given yn plus 2 minus 4 into yn equal to 0, comma y of 0 equal to 0, y1 equal to 2. Now we will apply Z transform on both sides. If you will apply Z transform on both sides, Z transform of yn plus 2 minus 4 into yn equal to Z transform of 0. Now I can simplify this applying the formula. Z transform of yn plus 2 minus 4 into Z transform of yn equal to Z transform of 0. What is the Z transform of yn plus 2? We know that Z square into y bar of Z minus y naught minus y1 into Z power minus 1 minus 4 into Z transform of yn. What is the Z transform of un is u bar of Z. This one should be 4 into y bar of Z equal to Z transform of 0 is 0. Now I'll multiply this Z square into y bar of Z minus Z square into y naught. Z square into Z power minus 1 should be Z minus Z into y1 minus 4 into y bar of Z equal to 0. Now y naught equal to 0 here, y naught equal to 0, y1 equal to 2. Now I'll write Z square into y bar of Z minus Z square into 0 minus Z into y1. What is the value of y1? y1 is 2 minus 4 into y bar of Z equal to 0. Now I'll write Z square minus 4 into y bar of Z minus 2z equal to 0. Now I'll write Z square minus 4 into y bar of Z equal to 2z. Now I'll write y bar of Z equal to 2z divided by Z square minus 4. I'll write. This is y bar of Z. Now this one only see, already we know that. So how do you simplify this one? Using partial fraction, we can simplify this problem. Right, now I'll take this one. Y bar of Z equal to 2z divided by Z square minus 4. I'll write it as Z plus 2 into Z minus 2. I'll write Z minus 2. I'll write. In next step, according to the partial fraction concept, I'll write y bar of Z divided by Z equal to 2 divided by Z plus 2 into Z minus 2. Now I'll write y bar of Z divided by Z equal to a divided by, see here, a divided by Z plus 2 I'll write plus b divided by Z minus 2. Now this only I'll write 2 divided by Z plus 2 into Z minus 2 equal to a divided by Z plus 2 plus b divided by Z minus 2. We cross multiply this, we'll get 2 equal to. So we'll get 2 equal to a into Z minus 2 plus b into Z plus 2. 2 equal to a into Z minus 2 plus b into Z plus 2. That's b into Z plus 2. We'll write like this. Now, if you'll put, this is, I'll take it as equation number 2. Previous one, I'll take it as equation number 1. Previous one, I'll take it as equation number 1. This is equation number 1, I'll take. Right. Now, put Z equal to, say, put Z equal to 0 in equation 2. Sorry, Z equal to 2. Z equal to 2, not 0. Z equal to 2 you can put. If you put Z equal to 2, you will get 2 equal to 4b. B equal to 1 by 2. Next, put Z equal to minus 2 in equation number 2. We'll give Z equal to minus 2 in equation 2. 2 equal to minus 4a. So A equal to minus 1 by 2. 1 should be B equal to 1 by 2. A equal to minus 1 by 2. Now I know that the values of A and B. Now I can substitute A value, B value in equation number 1. We'll substitute in equation number 1. What is the equation number 1 is nothing but y bar of z divided by z equal to A is nothing but minus 1 by 2 into 1 divided by z plus 2 plus b. B is nothing but what is that? B is nothing but we know that B is 1 by 2 plus 1 by 2 into 1 divided by z minus 2. Now y bar of z equal to, we'll write minus 1 by 2 into z divided by z minus of minus 2 plus 1 by 2 into 1 divided by z minus 2. That means here z I am multiplying, this side z I am selling. Now, so you'll apply. Here what we have to do, we have to apply the z inverse. So if you'll apply z inverse, so what we will get, y bar of z is there. So for y bar of z, if you'll apply z inverse of y bar of z, z inverse of y bar of z equal to minus 1 by 2 into z inverse of z divided by z minus of minus 2 plus 1 by 2 into z inverse of z divided by z minus 2. Now I'll write minus 1 by 2 into minus 2 power n plus 1 by 2 into 2 power n. Now what is y bar of z is nothing but already we know that z inverse of z divided by 2z divided by z square minus 4 equal to minus 1 by 2 into minus 2 power n plus 1 by 2 into 2 power n. So if you want, you can simplify this. LCM you can take and you can simplify. Otherwise, you can leave up to here also. Right. Next problem I'll simplify. Next problem. Solve by using Z transforms. Solve by using Z transforms. Solve by using Z transforms. Un plus 2 minus 5 into un plus 1 minus plus 6 into un equal to 0. Here u not equal to 1, where u not equal to 1, u1 equal to 0. u1 equal to 0. Right. How do you simplify this? Solution. Given, what is that? Given should be given un plus 2 minus 5 into un plus 1 plus 6 into un equal to 0. What is the condition? Condition is nothing but u not equal to 1, u1 equal to 0. Now I will apply Z transform. Z transform of un plus 2 minus 5 into un plus 1 plus 6 into un equal to Z transform of 0. Now if you will apply Z transform on both sides, so you will get Z transform of un plus 2 minus 5 into Z transform of un plus 1 plus 6 into Z transform of un equal to Z transform of 0 is 0. What is un plus 2? How do you write un plus 2 means Z square into u bar of z minus u naught minus u1 into z power minus 1. minus z transform of un plus 1 is minus 5 into z u bar of z minus u naught plus 6 into u bar of z equal to 0. Now I'll multiply this z square into u bar of z. I know that what is that condition? Condition should be what that u naught is nothing but u naught is 1. U naught is 1 minus u1 is 0 into z power minus 1 minus 5z into u bar of z. U naught is nothing but 1. U naught is 1 plus 6 into u bar of z equal to 0. Now I can write this one. So if I'll simplify z square into u bar of z minus z square minus 5z into u bar of z plus 5z minus 5z into minus 1 should be plus 5z plus 6 into u bar of z equal to 0. I'll write z square minus 5z plus 6 into u bar of z minus z square plus 5z equal to 0. I'll write z square minus 5z plus 6 into u bar of z equal to 5z minus z square. 5z minus z square. Five z minus z square divided by, if you send this one that side, you will get 5z minus z square divided by this one. If you send this side, so 5z minus z square. Next step I'll write u bar of z equal to 5z minus z square divided by z square minus 5z plus 6. Right. So now we'll take, let's see, I'll take this one. I have simplified up to here u bar of z. Now I can apply the partial fractions. How do you apply the partial fractions? So if you'll apply the partial fractions, you will get that 5z minus z square divided by z square minus 5z plus 6. Now I'll get 5z minus z square divided by z square minus 5z plus 6. I will write it as z minus 2 into z minus 3. I'll write fractions. Now I'll write in next step this one only, what is that, u bar of z. In next step, u bar of z divided by z equal to 5 minus z divided by z minus 2 into z minus 3. Z minus 2 into z minus 3. Right. Now I can take the values and I will simplify here. How do you simplify this? We will take 5 minus z divided by z minus 2 into z minus 3 equal to a divided by z minus 2 plus b divided by z minus 3. We cross multiply this. This is equation 1 I will consider. So now I'll write 5 minus z equal to a into z minus 3 plus b into z minus 2. B into z minus 2. This is equation number 2. Now put z equal to 3 in equation 2. We'll give z equal to, put z equal to 3 in equation number 2. We'll give z equal to 3 in equation number 2. So what we will get, a term will become 0. Z equal to 3 means 3 minus 2 is 1. 5 minus 3 is 2. 5 minus 3 is 2. 3 minus 2 is 1. So that equal to 2, b equal to 2. B equal to 2. Next, put z equal to 2. What 2? Plus 2 only. Put z equal to 2 in equation number 2. We'll give 2 means in equation number 2. What is that? 2 minus 2, 0, b term. 2 minus 3 is minus 1. 5 minus 2 is 3. A equal to 3. A equal to -3 you will get, not +3, -3 you will get. Right. So A is -3. Now we can substitute A, B values in equation number 1. Substitute A comma B values in equation 1. If you substitute in equation 1, you will get, what is that? 5 minus Z divided by, that is nothing but, what is that? Z minus 2 into Z minus 3. This only I'll write U bar of Z divided by Z equal to, what is that A value should be? A is nothing but, we can take -3. -3 into 1 divided by Z minus 2. B value should be 2. 2 into 1 divided by Z minus 3. Now we'll write U bar of Z divided by Z equal to -3 into 1 divided by Z minus 2 plus 2 into 1 divided by Z minus 3. Now I'll write U bar of Z equal to -3 into Z divided by Z minus 2 plus 2 into Z divided by Z minus 3. Now I will apply inverse Z transform on both sides. Z inverse of U bar of Z equal to -3 into Z inverse of Z by Z minus 2 plus 2 into Z inverse of Z by Z minus 3. Now this one should be, I'll write it as UN equal to -3 into 2 power n plus 2 into 3 power n. This is the required solution for the given problem. Right. We'll see one more problem in this. Next question. Solve by using Z transforms. Solve by using Z transforms. Solve by using Z transforms. Z transforms. Yn plus 1 plus 4 into 1 by 4 into yn equal to 1 by 4 whole power n. 1 by 4 whole power n, where n is greater than or equal to 0, comma y not equal to 0. Y not equal to 0. Now, solution we have to take. Solution. Z transform, sorry, given should be yn plus 1 plus 1 by 4 into yn equal to 1 by 4 whole power n. Is a given thing. Y not equal to 0. Now, we can apply Z transform on both sides. Z transform of yn plus 1 plus 1 by 4 into Z transform of yn equal to Z transform of 1 by 4 whole power n. Now, if you will apply this formula, we will get Z transform of yn plus 1 is nothing but Z into y bar of Z minus y naught plus 1 by 4 into y bar of Z equal to Z transform of 1 by 4 whole power n is Z divided by Z minus 1 by 4. Z transform of k power n is nothing but Z by Z minus k, like that, Z divided by Z minus 1 by 4. Now, the value of y naught should be here, y naught equal to 0. Now, Z into y bar of Z plus 1 by 4 into y bar of Z equal to Z divided by Z minus 1 by 4. Now, if I'll take y bar of z outside, so we will get z plus 1 by 4 equal to z divided by z minus 1 by 4. Now, if you send this one to that side, so you will get y bar of z equal to z divided by z plus 1 by 4 into z minus 1 by 4. Now, if we'll take this one to this side, y bar of z divided by z equal to 1 divided by z plus 1 by 4 into z minus 1 by 4. Z minus 1 by 4. We'll take this one only. 1 divided by z plus 1 by 4 into z minus 1 by 4 equal to a divided by z plus 1 by 4 plus b divided by z minus 1 by 4. Now, if you cross multiply this, so you will get 1 equal to a into z minus 1 by 4 plus b into z plus 1 by 4. Now, this is, I'll consider as equation number 1, and this one should be equation number 2. I'll take here, if you want, before equation number 1, so you'll take y bar of z divided by z equal to. Now, put z equal to 1 by 4. So, a1 equal to a into 0 plus b into 1 by 4 plus 1 by 4 should be 2 by 4. Now 2 by 4 is 1 by 2. So we will get b equal to 2. B equal to 2. Again, put z equal to 1 by 4 in equation number 2. Equation number 2. Next one should be, put b value should be 2. We know that. Put z equal to minus 1 by 4 in equation number 2. Put z equal to minus 1 by 4 in equation number 2. We will get 1 equal to, a is nothing but minus 1 by 4. Minus 1 by 4 means a into minus 2 by 4. B into minus 1 by 4 plus 1 by 4 is 0. So minus 2 by 4 means a equal to minus 2. A is, you will get, a value should be, what is that? Minus 2 you will get. A value should be minus 2. Now, we can substitute this in equation 1. Substitute a comma b in equation number 2. So if we'll substitute in equation number 2, now we'll get y bar of z, not equation number 2, in equation number 1, y bar of z divided by z equal to what is that? A value should be, a is nothing but minus 2. Minus 2 into 1 divided by z plus 4. B value should be 2. 2 into 1 divided by z minus 1 by 4. This is z plus 1 by 4. This is z minus 1 by 4. Now, y bar of z equal to minus 2 into z divided by z plus 1 by 4 plus here 2 into z divided by z minus 1 by 4. Now we'll write z inverse of y bar of z equal to minus 2 into z inverse of z divided by z plus 1 by 4. I'll write it as minus of minus 1 by 4 plus 2 into z inverse of z divided by z minus 1 by 4. Now this one only I'll write yn equal to minus 2 into minus 1 by 4 whole power n plus 2 into 1 by 4 whole power n. Now this is the required solution for the given equation. If you want, we can take 2 outside and you can write. So otherwise, we'll stop the problems up to here.